Good morning, everyone. Now, all of you guys know me. I'm David Tusubira, CEO and co-founder of NileOrbital, and also CEO and founder of Dojo Hub. NileOrbital Aerospace is a startup company that is being incubated by Dojo Hub here at the College of Engineering. So, essentially, like I said, NileOrbital is a space technology. It's a startup. It's a space technologies startup company. We're looking to develop space technologies in Uganda, okay? And I think we may be the very first official company doing something like that. We want to get into everything space, okay? So anything that you can imagine about space, satellites, rockets, we would like to get our hands into that. Of course, you guys know the country you're in. We live in a third world country, and you can't recall seeing anything space-related aside from the satellite that we launched last year, okay? So the first thing we're going to do as NileOrbital, our first mission, is to build local capacity by imparting skills among students and trying to exploit whatever opportunities come our way, and also doing R&D of different subsystems in order to build that capacity and get to the point where we have Ugandans producing satellites, rockets, or any other space-related technology. You could even be building space stations, okay? And someday in the future, okay? So just to give you a bit of background about why we're doing this, okay? Why would a bunch of Ugandans from wherever want to start getting into space? We all know what people talk about space and what people think about space. It's out there. You know, it's people are suffering with water where you're here trying to do space. People don't have energy. People don't have health care. Why are you doing space? Okay? People don't have iron sheets. Yeah. So why? What's the deal? Why are you guys into space? Well, one of the reasons is the satellite market. Okay? Satellite market is growing, partly because of the advancements in technology that are leading towards, miniaturized satellites. So because people are now producing small satellites, now there's a chance for people who have less resources to also jump in and participate in that market. And you've seen Uganda launched a satellite last year. Rwanda and Kenya had probably already launched one. Zimbabwe. African countries are now launching satellites. So that means that there's a growing satellite market even in the developing world. So that's an opportunity that is worth exploiting, okay? Our geographical location, Uganda is at the equator, okay? Being at the equator gives us an advantage because, as you know, when rockets are flying into space, they rely on the Earth's rotation for a bit of a boost, okay? And it's at the equator where you have most of that energy, okay? So launching rockets from the equator line or from equatorial regions gives you that advantage because you have the maximum boost from Earth. And hence, it could reduce on the resources that you need to incur in order to achieve space missions. Of course, it's more beneficial for satellites that are orbit bound, but still, it's an advantage nonetheless, right? Geostationary orbit. Okay, the other reason is that whether you like it or not, humanity is bound to be a multiplanetary species, okay? May not happen now, may not happen 10 years from now, but it is going to happen. It's bound to happen because there's nothing else to do, okay? People are going to get tired of this world. People are looking for other things to do, things to explore. Just the human curiosity, the spirit of curiosity, just human ingenuity, with those two things, you can guarantee that human beings will actually figure out a way to become multiplanetary. And if we consider that is a fact, if you believe that is actually going to happen, then this is the time to actually get into it, okay? Of course, there are other things that are going on, okay? You have things like metal 3D printing, okay? People are 3D printing rocket engines, yeah? Just like that. You have a rocket engine, 3D printing rocket parts, 3D printing satellite parts, okay? CubeSats, a satellite costing less than $50,000, launching a satellite costing less than $10,000. This is if you told this to people in the 50s during the Apollo missions that you can launch a satellite with a budget of under $100,000, they would think you're nuts. Okay, so these are some of the things that are happening now. In case you don't believe that humanity is bound to be a multiplanetary species and that people are going to continue pursuing space exploration, here's another reason to make you believe it. The Chinese are aggressively pursuing space. And for as long as the Chinese are pursuing space, the Americans will pursue space because they cannot allow anyone else to get further than them. So because of that competition, it's never going to stop. Okay? The moon, Mars, all that stuff is going to keep on happening because the West cannot just watch while other people are doing it. Okay? And now if Ugandans also start doing it, you don't know now what's going to happen. Okay? Okay. This is, I wouldn't say this is the biggest reason, but it is one of the big rationales. The fact is right now, the space industry is, around $500 billion. And by 2040, it will have hit $1 trillion, according to projections. Okay, so we're looking at $1 trillion market. If you're looking at $1 trillion market and you're just 0.00001% of that, you capture 0.0001% of that market share, yeah, you're guaranteeing $1 billion in revenue in a year. If you're just taking 0.001%, if you take 0.00001%, you can guarantee $1 million in revenue in a year. Okay, so it's a very big industry, and in whatever small way you play in, there is a big opportunity there. Okay. Now, as NileOrbital, what are our objectives? What exactly are we trying to achieve, at least in the near term? Our main objective is to build sustainable local capacity in space technology or spacefaring. Okay, we don't just want Ugandans to launch a rocket one time, be happy, and then after that, 20 years down the road, nothing is going on. Like what happened with the Apollo missions, where people went to the moon in the 50s and 60s, and then they stopped. And now 2022 is when we decide to go back. Okay, that's not what you would call sustainable. We want to build capacity such that when Ugandans start actually playing in the space, on the space stage, it is sustainable. We can guarantee that it is going to keep on developing and keep on growing. Okay, so to that end, we have 4 specific objectives. One being research and development of spacecraft subsystems. So with spacecrafts, we're talking about anything that is built to be in space, whether it is a space robot that is moving around the moon's surface or Mars, whether it is a space station that is hovering around in low Earth orbit, or if it is a rocket that is taking satellites into LEO or GEO.
Even these ships, like tires, you can start making them from here.
Exactly. Yeah, it's a very, very big industry. It's a very, very big industry. So we're looking at everything, okay? How can we build spacecrafts that are actually space-bound and that can actually survive in space and actually carry out services, okay? The second objective is to impart these competences of building spacecrafts and building space services. We want to impart these competences on the local populace because we want to rely on Ugandans to do these things. Okay, we don't want to have to fly in expatriates every time. Okay, that should only be for the short while until Ugandans get these things. We have Ugandans who have got masters and PhDs in these things that are doing this work. So 3 years from now, I'd like to see Ryan with a master's in aerospace engineering, obviously from a foreign entity, but at least I would be very happy to know that we have a guy in some part of the world who is actually learning these things, and we can rely on them for whatever things that we might identify, whatever work that we may have, okay? Then, of course, the third specific objective is to establish partnerships. Of course, the establishment of partnerships facilitates everything that we're trying to do, okay? Uganda is a third world country. Actually, in order for Uganda to even launch that first satellite, it was a partnership with the Japanese Space Agency through the BIRDS 5 project, okay? So the fact is the only way we're going to get into this industry and survive in it is by establishing both local and international partnerships. Local partnerships are with, government entities, and other private entities that might be playing in this industry, maybe customers who need these services, okay? And then internationally, of course, you have universities, space agencies, individuals who are highly skilled from which we can draw knowledge and share with the local populace. And then lastly, and probably even most importantly, is to identify and exploit opportunities. We know that the space industry is large, we know that the market is large and growing extremely fast. So what are these opportunities? Can we provide internet through satellites? Can we have a constellation of satellites that are supporting communication or maybe Earth observation? Or can we actually build rockets and provide launch services? What is that opportunity? What are those opportunities? What are those niches that we can actually identify and furnish and, you know, make some money and be sustainable? NileOrbital Aerospace was founded by 3 individuals. Myself as the CEO, Nicholas as our Chief Commercial Officer, and Nav as our CTO. So the 3 of us founded the company last year after going through some different experiences and, you know, yeah, just to put it lightly, we went through different things to arrive at this. But what I can tell you is that the 3 of us are incredibly passionate about these things. Me personally, the reason why I want to explore space is because it just simply exists, okay? It's not because of money, it's not because of what, because it exists. Yes, for me, that's my reason. I don't have mob jazz about it. Nav wanted to be an astronaut at some point. Nicholas wanted to be an astronaut when he was a kid. So these are just, you know, people who are passionate about these things coming together and trying to make something happen. Of course, given the environment that we're in, what we're trying to do can be considered to be crazy, okay? And given that you guys have joined us, we can also classify you guys in that same category of crazies. I hope you're okay with it because anyone who has any great thing that you know in this world, anything that is great, anything that is worth paying attention to, started out like that, okay? So I'm glad that you guys are willing to take this risk of ridicule to be a part of this. And we guarantee you that we are committed to this mission. We are spending our own money and we are going to spend more of it. And we're going to look for money to do these things, okay? So you can rely on us to be committed to this and to keep pushing these things. At the end of the day, these things are about pushing and trying to keep things happening. It's not about luck or anything. Those things will always come in. But it's mostly about being persistent and pushing. Exactly, exactly. And we've failed many times. Yeah. Oh, and we are not space experts, okay? I'm not an aerospace engineer.
Software engineers, most of it.
Exactly. So you see me, I'm an electrical engineering graduate. This one is a business management man. This one here is in mechanical fabrication. So we're not really space guys. It's really mostly passion. So don't expect us to have some godly space knowledge, okay? We are counting on you guys to actually acquire more knowledge than us. For us, we just want to facilitate, okay? But yes, we want to establish the standard, say we want this, and you guys figure out how to do it. Yeah. Yep. Okay, of course, what we're doing has great benefits for our nation. Number one, if you're in the space industry and you're actually spacefaring, chances are high that the revenues you're turning are really, really high, okay? Upwards in the millions, which is good for the country's tax base. Space companies typically have more than 100 employees, okay? And we believe that NileOrbital will get there at some point. And of course, we know how important employment is to our economy. Now, of course, you guys are engineering students. You know the experience of studying here. It's mostly theoretical. I think that, you know, space is one of those opportunities to get people practically involved. If you look at countries like the US, which are very, very mature in space, technology, you'll find that, you know, after the Apollo mission, there were all these things like rocketry programs, and these things have been standardized. So you have like little kids launching, you know, model rockets, you know, and understanding exactly homemade model rockets. And these kids understand the principles of thrust. They understand the principles of velocity, you know, escape velocity, the atmosphere, all these things, okay? So I think having actual practice of space technology will boost science and technology education. Now, we all know that every security agency relies heavily on, you know, satellite technology for communication, for GPS navigation, and all that. And we know that Uganda has not yet built capacity to have their own satellites, or for the UPDF to have its own satellites or anything of that nature. We're probably relying on technologies that are appropriated by allies, you know, like Israel or US. Exactly. Actually, there's a lot of money that the UPDF is paying foreign people to come and maintain equipment that they bought from foreign people. Okay, so we believe that we can build capacity that will actually impact our local security, you know, agencies and entities, and of course contribute to national security. And then lastly, national pride. This is space stuff. It's something that people fear. Okay, so having Ugandans actually do these things greatly contributes to national pride. You'll be proud moving around the world as a Ugandan, knowing that there's a NileOrbital that is launching rockets and putting satellites into space. Okay. Okay. Now, to get to this internship, the 2023 NileOrbital Aerospace internship. Now, you guys already know, we have already given you some information about this, but the internship has two key objectives. One is to replicate the BPS space model rocket reaction control system. You guys have watched the video, okay, of Joey Bernard and his reaction control system. We picked that because it seemed like a low-hanging fruit. It's not a full model rocket with like a real rocket motor that is meant to fly up in the air. So it's not risky, it's not dangerous, no one is going to get harmed, no one is going to get injured. But at the same time, it is challenging, right? The other thing that makes it such a very good thing to start with is reaction control systems are applicable both on satellites and rockets. So it's like a way to actually attack both satellites technology and rockets and rocketry in one small thing, okay? And then the second objective is to design and simulate NileOrbital Aerospace's first rocket. Now, we don't know yet what that rocket is going to be. If it's going to be a model rocket or a high-power rocket. We don't know what altitude it's supposed to reach. That is something that we expect you guys to help us figure out. The first rocket that flies, that has the NileOrbital logo and the Ugandan flag on it, what kind of rocket is it going to be? Because you, the mechanical guys, are going to design it in this internship, okay? So in designing, of course, there's developing the specifications, then actually going about designing and simulating the thing, okay? So that will be the second objective. And that will prepare us for the next stages where we will actually... Yes, we're going to obviously start with motor scale, yeah. The rocket that we're going to design in this internship has to be one that we're actually practically going to now attempt to fly after this internship. Okay. Now, of course, yes, the reaction control bit is based off of BPS space. It's I would say it's a space. I don't know if you call BPS space a space company, but I guess it is a space company in its own right. The proprietor is Joe Bernard, who we have spoken to and gotten some insights from. He basically builds model rockets. He's commonly known for building SpaceX replicas, but he's most popular for successfully building landing model rockets. He's the first person to successfully land model rockets, and probably even the only one who has done it up to date successfully. Now, what activities are we going to be doing in this internship? Of course, we shall have lectures. So we'll have some people come in and introduce certain concepts. But most of the things that you will learn, new things that you will learn, or things you'll be reminded about, will come from the content that you will share, which is a bunch of videos and some notes here and there. And then, of course, we shall actually develop the reaction control system, that is assembling it as is in the BPS, as the BPS thing is, and actually programming it and testing it, okay? And then, of course, there will be the rocket design, which the mechanical guys will do after assembling the reaction control setup. And then, of course, we shall try our best to document this internship. As you can see, we're documenting this lecture. So we'd like to document the lectures. We will also try to document some of the assembly activities, design activities here and there. And we shall also try to document some meetings, okay? Some get-togethers that we have, follow up on progress and all that. So this is what we're trying to achieve.
The controller for this is still very rudimentary, so don't expect anything crazy. So we're going to press for flight now, and we're pressed.
Yeah, that is the task. Now, this task is actually harder on the electrical guys than on the mechanical guys, okay? The mechanical guys will assemble this thing in a week if they have everything they need. The electrical guys are the ones who are going to huff and puff to get the thing to actually do what it's supposed to do, okay? It's, I have to tell you, it's quite challenging. And Joe Bernard does not share firmware, he doesn't share his code. So we're going to build the code from scratch, okay? Okay. Yeah, thank you, Joey. All right. So the internship is expected to last 8 weeks, maybe 7, okay? The first week, which we're already in, is just for introductory concepts. So that list of videos that I shared in the learning guide, all those videos, apart from the last ones which are only for the electrical guys, you have to watch all those videos, because once you've watched all those videos, and once I'm sure that all of you guys have watched those videos, at least I know where you are in understanding these space things, okay? So that we can start throwing out terms, and I know that these terms are not new to you, okay? So that's what the first week is about. Walk through those videos, try to even find additional content to support understanding some of those concepts. And still within the first week, we shall have some introductory lectures. One of the lectures is, we shall have a lecture on CubeSats that will be delivered by Edgar Mujuni. Edgar Mujuni is one of the 3 guys who went to Japan to build the first Ugandan CubeSat. So he actually is doing a CubeSat research project. He's building a LoRaWAN CubeSat, and actually we will be adopting that project as well and figuring out a way to work with him to actually build a CubeSat. Then after the first week, which ends, of course, next Thursday actually, we shall now start on the parallel task. So the mechanical guys will start assembling the reaction control, setup, compressor, and also testing if the thrusting works, And then we'll have the electrical guys will be going through the avionics content. So those videos from the landing model rocket series of BPS space, basically how to assemble that blip flight computer and have it ready to control the reaction control setup. Yeah. So we expect that to take 2 weeks, but I know that the mechanical guys may finish faster. Okay. Then after that, we shall get into. So after every of the electrical guys learn how to, work the computer and how to design it, they'll also assemble it. So that means because we design a PCB and then order it and then assemble it and then move on to programming. Okay. So basically, you spend like a month getting the flight computer ready for the reaction control setup. But the mechanical guys, after building the reaction control setup, will now focus on designing that first NileOrbital rocket, probably Uganda's first real almost real rocket. I've seen some guy who launched some kind of thing some while back, but that is not something that you can say.
Rocket fusion is actually like part, like for only rockets, like fusion by different parts. So
Yeah. Yeah, I'm sure there's a bunch of people that have tried a few things, but we're not trying to do, rudimentary things. We want to do something that's professional, something that we can actually put the Ugandan flag on and be proud of. Okay, something that can fly to a respectable altitude. Okay, and be recovered safely. Okay, recovery, very important. Yeah, and also with like proper solid. Well, I think we'll probably start with solid state fuels, maybe even water pressure. But at the end of the day, we want our first rocket to be something that's presentable, something that we can tell a good story about. Okay. And that, of course, rests on the mechanical guys. And then, yes, once the electrical guys are done getting the flight computer ready, they will spend the remainder of the internship programming the thing to actually achieve two-axis control. We shall first do one axis, okay? So actually, this is the gyro. So this is the gyro that we'll use. Oops. So you can see that the reaction control, the airframe will be in the middle, okay? And it will be able to dance freely. This is the thruster thing. It will be like up here and it will be, Yeah, so we shall first lock one axis and only have one axis movable, and then get the guys to balance it on that one axis, and then we can now open up the other axis and have proper two axes. Now, you guys already know this is not a very simple task, so please give this your all. And look, this is obviously not. This is not like those projects where it's like a thing that you can now turn into a product. In the like very very small things. No, this is not that kind of project. But I can assure you that it's even more satisfying than those kinds of projects because of that how challenging it is. Okay, getting that control to work, it's going to be more satisfying if you can actually get that to work. So I'm urging you guys to please do everything that it takes to get it to work. That satisfaction will actually build your confidence in ways that you don't know, in ways that you haven't yet recognized. Okay, and yes, of course, this will be beneficial to you in your careers. Your exposure to these space concepts, your internship with NileOrbital and actually building spacecraft subsystems will actually give you an advantage in maybe applying for a master's in a foreign country, okay? Because usually when you're applying for like a master's or even a job, okay, in this industry, people look at experience. Where have you worked? What have you done? But people very much like prototypes more than experience, because a prototype tells the whole story. You built this thing. I don't need to ask you any other questions, okay? So please take this seriously. It will reward you immensely. So what are the next steps after this internship? What is NileOrbital looking to do? Well, we intend to continue hosting these kinds of internships, okay? So we shall always have an internship every year around this same time, where we will have multidisciplinary teams of students trying to achieve a subsystem task, okay? Now, today it's reaction control. Next time it might be a proper thrust vectoring thing, okay? Who knows, depending on how far we'll have gone. Actually achievable. You can achieve them with small budgets, okay? It's the mechanical things that should survive the vibrations of a rocket that's what makes it expensive. But the communication, the computer, it's actually not that expensive. It is achievable. We can achieve it with the monies that we have. So that's the big thing that we're looking at. Now, of course, Uganda is not considered a spacefaring nation, but there are very many people who have been in Uganda who have been practicing, who have been doing space-related services, okay? But the space-related services that people have been doing are more to do with the geospatial stuff, okay? Like getting satellite imagery to analyze someone's farm and see which crops are lacking water and what, or using those multispectral cameras to find the potential of minerals being in a certain area. These things Ugandans have been doing for a very long time. Okay, these are the services that have been there for long. Satellites have been doing these things for long. Okay, so we also want to build more capacity in there because, as you guys know, we are in the advent of artificial intelligence, and artificial intelligence is now, meeting up with space, and interesting things are happening. And we also want to be one of the people that are R&Ding that and trying to discover new services by pairing emerging technologies with geospatial data to achieve, incredible insights and new services. Okay, and then lastly, and probably even most interestingly, we are going to pursue a model rocketry project where we shall actually build and fly model rockets, high-power rockets. Maybe I would say our key short-term objective is to actually build a high-power rocket that touches space, that crosses the Kármán line. We had, in the meeting we had with Joe Bernard, he actually told us about some guy who built a high-power rocket that touched the Kármán line with under $50,000. So if you can actually achieve a space shot with under $50,000, I can guarantee you we're going to try our best to make that happen. So because we don't think that $50,000 is a barrier to something like that. I think we shall try our best, and we will actually go for it, because otherwise what else are we doing? Okay. Yes, that is it. Thank you guys for paying attention to me. Do we have any questions?
Sorry, I'm very curious.
Yes.
Are you already gonna go with like already existing engine prototypes, or you guys want to go? Because I mean,
very good question. So actually, one of the things that I missed in this slide, a liquid propelled, yeah. So we're also going to, in parallel, we're going to start an actual liquid propulsion project, actual liquid engine. So, because you see with liquid engines, and if you're building like a real rocket, like proper rocket that is meant to fly many times and eventually fly human beings, it has to be liquid propelled. Or you can do solid rockets. People have done them successfully. The Indian government, Iranians, even the SLS that launched last year started off with solid boosters. Okay, so yeah, you can actually achieve a lot of success with solid rockets, solid propelled rockets, but it is not actually all the way sustainable. Everyone who's doing solid rockets wants to get to liquid. Okay, so we don't want to waste time. If we can, we will actually have a team of students building an actual liquid propelled rocket. And in our call with Joe Bernard, he showed us a bunch of people who have found a clever way of building liquid propelled rockets on a low budget. Okay? Yeah. Yes. Exactly. Yes. Yeah. Yes, so of course most of the challenges are usually around cooling, but they figured out a clever way of cooling the engine. So we're going to explore that and see how to get a group of students start on that project as well.
First, we're also going to build a test stand.
Because I
You have to pay the infrastructure to handle the power and to see
the thrust vector for each.
Yeah, so I think we can say that 3-4 years from now, you can book it. We will have a rocket testing party, and you will see a thing roaring. I can guarantee you that. Yes.
So within this, you have like a materials department. Like with each rocket part, you have to test like which grade of steel, which grade of like materials department.
There has to be, of course, you cannot do a rocketry project without a materials department. There has to be, well, they can still be mechanical engineering students, but they can also be people like who are proper in material science. Yeah. Unfortunately, I don't think in Uganda there's any university that's offering a material science course. In Kenya, there are people who do material science, but here they're not.
So, but you're also going to go with the already existing.
Well, the materials are completely from each
the material is not available on
Because the whole point of concrete is to get something strong.
something strong and light. So it doesn't oxidize how it breaks.
So we're going to be using particular alloys like internal and also aluminum. Light and strong. That's what we're going to do.
Yes, the reason why one of the reasons why we are confident that we are going to achieve these things is because we have NAV. NAV has a workshop, a full-blown workshop, mechanical fabrication workshop with all the machines you can dream of, okay? So we know that we can fabricate these things. Yeah, and we'll definitely get there. Any other questions?
Are there any more resources apart from the resources that you offer in
I imagine that there are, but I personally have not tried so hard to look for them. That is your job. It's not my job. You guys, I've given you that learning guide.
Yeah, it's like open source.
Flight computers are actually very similar across different kinds of flying objects, okay? So there are very many similarities between like rocket flight computers and drone flight computers and RC flight computers. Yeah, because it's the IMU, altitude stuff, and then also gyros. Oh, there's a lot of similarities. So I would say it's not, the knowledge is there, and it is there in open source, and it is there for free. It's very common. Even for the rocket design, you're going to use an open source software called Open Rocket, and there are very, very many tutorials online for it. So we shall ask Joey if he has any tutorials that you would recommend, but there are tutorials on Open Rocket. I even downloaded some a while back. But for the flight computers are very common. People have been doing them for long. So yeah, you'll find these things. But still, again, I have to say, this is rocket science. Okay, this is not a joke. Yes, we can do. We are saying that these things are doable, but this is rocket science. Okay, so switch on your highest gear. That's what we want. Don't come here with your half. No. You can't half-ass this stuff. Okay, this is the real rocket science that you hear about, and there's a reason why it is used as an analogy for anything that is complicated. Yeah. So this is not a simple task. We are calling upon your very best. Yes. Any other questions?
Anyone else who is interested in this kind of stuff, please bring them.
Yeah.
The more minds we have, the better.
For us, we're not trying to colonize this industry. I'm not trying to be a rocket PhD, aerospace PhD. I know enough things. Okay, I know too many things, and they're enough.
The more the network grows, the easier and the better it becomes. The more we have in this thing, the better it is. So even if anyone who's interested, any of our friends,
we want to partner with anyone.
Something else, but they're interested in rockets and stuff.
Bring them on. I mean, for me, I recall. Not necessarily even well versed, but interested. I think the most important thing is the passion. Yeah, when someone is passionate, even if they're not, they will fight and they will get things done.
And they're doing other things.
Yeah.
So we give them the opportunity.
NileOrbital is a vehicle for those people who are passionate. We want to meet them.
How we started it. So
yeah, even us we're just yeah. So we want everyone and anyone who is interested in these things, want to give them a chance to contribute to our vision and mission. So please, anyone who you identify who is genuinely passionate about these things, please bring them to us and we'll see how we can work with them. We want to work with everyone. Okay, any other questions?
This is a bit out of, but it talks about partnerships. Is there any plan to partner with maybe government of Uganda, Ministry of Technology?
Very, very good question. So we have been trying to partner with local entities since the very beginning. Now, we applied for a grant from so there was a call for applications by the Secretariat of Science and Technology Innovations, and we applied for a grant. The grant was for we want to build a prototype of a 3U CubeSat. So the 3U CubeSat will have a LoRaWAN transceiver for IoT communication, and then it will also have a camera for taking high-resolution Earth observation images. So it's basically building a 3U dual-purpose CubeSat for both Earth observation and IoT communication. We've identified IoT communication as the lowest hanging fruit in the satellite value chain, okay? Because you can actually provide an IoT communication service, yeah, with gateways, like, of course, low Earth orbit gateways, with just a handful of CubeSats, 1U CubeSats, you can actually provide services for IoT, because essentially you just have CubeSats. You just need to ensure that at least every hour there is one that passes by that the ground nodes can communicate with. Yeah. So you can have a constellation of 6 of them, and you can actually somehow hold a service, an IoT service. Because with IoT, the sensor nodes can wait for the satellite to come around. So for them, they can know how the CubeSats are moving, and they know when one has come, and then they upload the data. Then, when there's no CubeSat, when there's no satellite in nearby, they store the data. Then, when the satellite comes around, they upload. So you don't even need to have full coverage where there is always a CubeSat over our space. You don't need a large constellation. So yes, but then still, to answer your question, we also have approached the UPDF, the Nakasongola Enterprise Corporation. Now, we're actually in the process of securing a NEC partnership, okay? Because I don't think we'll be able to fly anything without that authorization. Yes, it's a weapon. Yes. But we actually, the reason why we decided to attack everything at once is because we realized that, initially we actually were focused on rocketry. But then rocketry had too many roadblocks, okay? Because it's too sensitive. Anything that you build, any small rocket that you build is a weapon, okay? So we realized that we can't afford to be stagnated by the due process of building rocketry capacity, which is why we had to get into everything else as well, okay? So we know that building a CubeSat prototype, no one is going to stop us unless the thing is communicating, and now you're doing communication regulation, of which LoRaWAN is a standard frequency band that we can use without having to talk to anyone, unless you're doing large scale, and then now you have to involve UCC, okay? Those are things that are known, okay? But yes, we have tried and we will continue trying to partner with the government, and we know that we shall get those partnerships will develop as we continue to build more and more capacity. Normally, the government will ignore you until you're too big to ignore, okay? Yes?
So ultimately, we're also going to be partnering up not only with
They're not just
International. Yes.
most during those partnerships, like, do you only look at the financial part of the partnership? So are you willing to budget with like other, like let's say universities or like space agencies that are already working on
Yeah, it's not all about the money, it's about exposure. Right now, what we need more than money is knowledge, okay? We need access to people who have built satellites, people who have built rockets. We just need to understand these things. We need to acquire knowledge more than we even need money. The knowledge first, and then the money comes after.
Because I was thinking it's easier for people who are working in this to have exchange programs, like Caltech, MIT.
I want to send all these guys to Caltech. I want all these guys to go.
I wanted to go to Caltech. This is one of my dreams.
We want to send these guys to those universities to go and study.
More exposure, the better.
Yeah.
I just go to
At the end of the day, you look like creating opportunity back home. So most people that need.
Looking for allowed to say about, if I'm allowed to say something about this one of you as well is going to be traveling soon.
We expect, yeah. So Joseph got accepted into a space station design workshop that is being hosted in Stuttgart, Germany. So he got accepted, and now we're trying to get the visa and flight stuff in order for us so that he can fly and go and, you know, be there, socialize with some people. Yeah, for us, we shall make noise about it. Yeah, so that's in the works. It's not, I would say it's not guaranteed because they're also funding. Those guys are like, their communication is not very good. Okay, they're not, the support that they're offering is not very, very clear. And those may be the things that may hinder us, but for us, we're going to try our best to ensure that he goes.
Now, basically, just asking what we're saying that we will support one of you and also others.
In whatever way we can.
Exposure
Yes.
for people working on it.
Writing recommendation letters, partnering with people who can get you
That
scholarships.
knowledge, yes, really, it's a very good scholarships. They tell you have to go back to, you know.
The knowledge will come back. The knowledge will come back. Even if you go to Germany and find a nice looking woman and you decide to stay there, at least we know that you have acquired this knowledge and we are in communication with you. So do not feel under pressure that, you know, no. The fact that you've gone out there and you've acquired this knowledge and you're affiliated with us is actually still valuable to us. But for us, that won't stop us from creating these opportunities and trying to have you guys go out there and acquire knowledge. Any other questions? Yes, please. Yeah, please.
So I was thinking in the beginning, so you guys are not using this space, so you have like a lab space prepared somewhere.
There's a lab space upstairs. I think we went there with you.
Yeah,
the one that we went up there. So there are workstations. Each of them has a workstation in the upper lab. And that's what they're going to use to do, you know. We will only use this for lectures. Yeah.
So like if I get concepts or anything like that, like help with the price of certain components, and you know what, 90, I swear I can just bring it.
Yeah, upper lab here. That's why the guys are. We expect them to be on a daily basis, especially when there's, you know, physical activity.